Hello and welcome back to the video series of CCA 175 Hadoop and Spark Developer exam preparation. Today I'm going to walk you through the solution of problem scenario 3. Now, as I mentioned here, this should be performed in the same sequence because I have created this problem in such a way that each step is interdependent and you can accomplish the next step only when you accomplish the previous step. So the first step is asking you to import all the tables from MySQL database into HDFS as Avro data files. And it is asking you to use compression, and the compression codec should be snappy. Now the data warehouse directory is retailstage.db. So let me copy this first and then go to the Cloudera Twig.vm. So I'm going to start writing the Sqoop import, okay, and say connect. I'll say jdbc equal quickstart.cloudera 3306/retail_db, and then username is retail_dba. Then I'm going to do password is Cloudera. um I think I should do import all tables, right? That is what the problem is asking you to do. All tables, and then I need a warehouse directory. Okay, I'll say warehouse hyphen dir is /user/hive/warehouse slash retailstage.db, and I'm going to use the compress option, and I'm going to use the compression hyphen codec is snappy, and then I'm going to use hyphen m1. So I just need one mapper over here. So let's see if I have accomplished all the things that are mentioned in the problem. So import all the tables, yes. HDFS, yes. Avro data files, no, not yet, because we need to specify this as Avro data file. Okay, and then this is two hyphens, not just one. So this can be one, and this is two compression codec. I have compress. I have the warehouse directory, password, retail. Okay, seems like I covered everything when you look at the way the problem is defined. So let me run this, and I will return to the screen when the execution finishes. Okay, I'm stopping right now, but I'm going to return later. Bye. Okay, the Sqoop command has finished execution. As you can see, you have there are no errors reported here. Let's try to quickly confirm if we have all the data that we need. I'm going to say /warehouse/retail_stage.db. Okay, so I have categories, customers, departments, order items, and orders. I think we are interested in this orders. So let me copy this and let's go back to see what the next step is. So this is saying create a meta store table. So every time when you see a question with meta store in it, that means it is referring to Hive. Hive is a meta store database. Now create a meta store table that should point to the orders data imported by the Sqoop job above. Name the table as orders_Sqoop. Now let's investigate what is there in the orders folder, which is called orders data, right? So fs-ls, and it'll be paste here. Okay, so what you see is an Avro data file. Now, for Avro data file, we need a schema. Okay, now without the Avro schema, there is no structure for Hive to understand how the data looks in the underlying data file. So we need to extract the schema from this Avro data file and supply that to Hive when we create the Hive table. Now, before we create the Hive table, let's try to extract it and see and understand the steps to extract the schema out of an Avro file. Okay, so for that, I'm going to create a folder in my local location, not on the HDFS, and I'm gonna move to that folder. Okay, so let me say Hadoop fs-get, and let me get this file so that I can extract the schema from that file. Okay, so copy, paste. Okay, now do an ls. So you have the file. So let me copy the file name. And in order to get the schema, all you need to do is say avro-tools and then say get schema and use this and output that to orders.avsc. Okay, so you can see orders.avsc is the schema file now. So let me look at orders.avsc. As you can see, this has order ID, order date, order customer ID, and order status, table named orders. Now what I'm going to do is just exit from here, and then I need to copy this into some place inside the HDFS. Okay, so let me create a folder, Hadoop fs-mkdir. I'm going to say /user/cloudera/schemas. Okay, so or I'll say /user/hive/schemas/order. Okay, for schemas, and then I'm going to create the orders directory, and then I'm going to use Hadoop fs copy from local orders.avsc into the orders folder. Okay, let me quickly check the orders schema folder, schemas/order. Okay, so this is where your schema file is. So let me copy this too. Now let me launch Hive. All you need to do is type Hive and then wait for it to be launched. So I'm going to pause the video and return when Hive launches completely. Okay, Hive is launched. Now, in order to create a table in Hive which points to an external file, we need two pieces of information, especially when it is a Avro data file. Okay, the first is the location of the Avro data file itself, and second is the location of the schema. And we have created a schema and uploaded that to HDFS recently. So let's try to copy those two locations. Before that, let's try to start creating the table. So create external table, and the name of the table based on the problem description is orders_sqoop. So let me copy this, paste, and then which is stored as Avro. So this is stored as Avro, and then I want the location. The location is as you can see, this is the orders location, right? So let me just copy this here. So location is orders. Then I'm going to give table properties is avro.schema.url equals. So I recommend using single quotes because sometimes Hive kind of behaves strangely when using double quotes. So I'm going to use single quotes, and then I'm going to copy this schema definition file. Okay, the reason I created an external table is even if you drop this table, the file in the background, the file which is the Avro file, which we have downloaded earlier, that file will not be deleted if you delete this table. Okay, so I'm just going to enter this expected string literal near the location. So let me try to do this again. And then I'm going to say stored as Avro. And for location, let me use a single quote, and then the table properties can be this. Okay, the table is created. Now let me do a select star from orders underscore scoop limit 1. Okay, so one record has been deleted, and then I'm going to do describe formatted orders underscore scoop. As you can see, this is the schema file that we just used, and here is the Avro data file itself. Now let's look at the next part of the problem. Next part of the problem is to write a Hive query. We just created a table called orders underscore scoop that was pointing to the Avro data file downloaded from MySQL. Now we are tasked to create a query that queries order table such that we get all the orders belonging to a certain day, and that day is when the most orders were placed. So first let's try to find out the day when most orders were placed and then utilize that data and find out all the orders belonging to that date. So in order to find out the most orders, so let me do a select y dot order underscore date comma count of 1 as total orders from orders underscore scoop as y, and I'm going to do group by y dot order underscore date order by total underscore orders descending limit 1. Okay, now this is going to be, this is when this finishes execution, I'm going to receive just one record, and because I'm sorting this result in the descending order of the total orders and extracting the first record, I'm going to get a record with the maximum number of orders in it, which means the order date, the total number of orders, and I think the order date and the total number of orders basically, these two fields but belonging only to one record, and that record is the topmost record of the descending ordered result set. Okay, I'm sorry if I confused you over there, but I'm trying my best over here. Okay, so this Hive converts the query into a map reduce job. As you can see, there's a mapper phase and a reducer phase. Now, after the map reduce job finishes, it's going to output the result to you. Generally, Hive will be using the traditional map reduce framework, but you can configure Hive to use Spark so that it is faster. However, if you run the same query in Impala, you will be getting the fastest result. So if you have to do some quick analysis on the data during the exam, you better use Impala, because that way the queries are going to be running faster, you're going to save time, and most importantly, you will have more time to deal with the remaining problems in your exam. Okay, so this gives you the result. Now I need this value, the first value, in order to fetch all the orders belonging to that day. So let me continue to evolve this. I'll say Z, and let me say select Z dot order date from here. Okay, so let me run this again. I'm just gradually evolving it because I need to extract the order date field from here and use that order date field for fetching all the orders belonging to that particular date. Now, while this is running, let me give you a little more about Hive as a metastore. Now, Hive metastore tables are not actual tables. They are mere views into the data that is available on HDFS in the background. Now, this kind of neatly abstracts and gives you a database like, an RDBMS like structure, or at least an illusion, and you will be writing queries on that illusion so that you don't have to deal with complicated map and reduce jobs. However, writing Hive queries may not be the best solution all the times. You may need much more optimization. You may need much more logic that cannot be accomplished using SQL in general. That is where the difference comes between a developer on the Hadoop world and the data analyst on the Hadoop world. The data analysts focus more on querying tools like Pig, Hive, and Impala, whereas developers focus more on the Spark and the processing side of it. However, being a developer um, requires you to be hands-on in Hive technology. So, being a developer on in the Hadoop world is equal to being a developer plus being a data analyst. Okay. Now this has finished execution. I'm able to fetch the one piece of information from the record that we identified earlier. Now let's try to take it forward. Okay. Now let me enclose this in brackets and then say select star from uh, orders underscore scoop as x, where x dot order underscore date in this result set. Now let me execute this. Okay, so um, now let's talk about some of the configurations you can do within Hive. Now Hive itself is a very powerful tool. You can create tables that can access data which is in different formats. You can use ORC files, which is optimized row columnar formats. You can use Avro data files. You can use Parquet data files, and you can use the traditional text files. No matter what file you use, the SQL that you are writing to access the data is going to remain the same. That is the beauty of Hive. And Hive uses internally things called as SERDES, SERDE. SERDES are nothing but serializers and deserializers. It has it comes by default with a bunch of SERDES to deal with different types of files, and these files can be compressed as well. In our case, we have downloaded these Avro files with snappy compression codec, but you didn't have to do anything special in order to access the data using Hive from Avro compression. Access the data using Hive even though the file is compressed using Avro. Um, so, so use Hive every time you want to simply extract or simply do some aggregation sorting or some aggregation over commonly available methods like mins, maximums, averages, and use Spark when you have to do much more complicated logic or you want optimization that is beyond Hive, because using Hive your optimization capability may be limited because it all depends on whatever the Hive package comes with, right? So let's wait for this job to finish, and then we can investigate the data and move on to the next part of the solution. The next part of the problem is to run the same query in Impala. If you look, it is exactly same logic, but you want to do this in Impala. In order to do this in Impala, launch a new terminal and say Impala -shell. You know, Impala has launched. Impala is pretty fast and it's pretty impressive how Impala kind of optimizes the query execution and gives you a fast result. So let me copy the same query that I wrote in Hive and run this in Impala. Okay, so before that, let me do show tables. Yes, I can see orders underscore scoop, paste, enter. Now see, Impala has run this query in 1 minute, 1.85 seconds, whereas Hive took 154 seconds. Isn't that ridiculous? So this concludes step number 4. Now let's look at step 5. Okay, now let's look at the step 5 of the problem. Create a table named retail dot orders underscore avro. Now retail is a database and orders underscore avro is a table name. So first we need to create a database. So let's try to create a database in Hive. Let's see the current set of databases. It has a default is the only database. So let's create database retail. Okay, now let's say show databases. You can see retail. Now if you do a DFS hyphen ls slash user slash hive slash warehouse, you can see retail.db. Now let's try to create what is the problem asking you to. The table should have same table definition as order underscore scoop. Additionally, this new table should be partitioned by order month. That is 2014-01 or something like that, right? Now let's try to use retail. Okay, now show tables. There are no tables, and I'll say create table. Let me first describe default dot orders underscore scoop. Okay, now let me create table, and the table name that we need to use is orders underscore avro. Orders underscore avro, and then I'm going to use the same schema int. However, for order underscore date, I'm going to use date column, and this way I can teach you how to do transformations using Hive. ID is int, order underscore status is string, and then partitioned by, let's say, order underscore month, which is a string again. Then I'll say stored as avro. Okay, now this creates an empty table. If you look at show tables, you have orders underscore avro. Now let's try to insert data into this table. All you need to do is, because this table is partitioned, you need to insert data in in a way that supports partition tables. So before we insert, because we want to have dynamically partition table, we don't want to statically say that insert this set of records into X partition and this set of records into Y partition. Let's try to enable dynamic partitioning in Hive. Now you need to remember these commands because you may have to create a dynamic partition table during the exam, right? So I'm going to say set hive dot exec dot dynamic dot partition equals true. This is the first parameter that you need to set. Then exec dot dynamic dot partition dot mode is non-strict, which means even when there is no single partition, Hive will still go ahead and create partitions when you insert records into this table. Then I'm going to say set hive exec dot max dot dynamic dot partitions dot per node. I'm going to use like maybe 300 partitions per node because we have a lot of orders in the order table. Now that we have this, let's try to write the insert statement. So for this, I'm going to say insert override. Um, insert override orders underscore avro partition is order underscore month. Okay, now I'm going to select order underscore id comma order underscore date, and I need to convert this into, so I'm going to say here from Unix timestamp, this is going to give me a date. This is a, the date column is a begin by default. It has milliseconds. I don't want milliseconds and seconds, so that is why I'm chopping off the last 3 decimal places as int. And then I'm going to say 2 underscore date. Okay, so this will be my second column. Basically, I'm just checking if I have closed all the brackets correctly. Okay, this is good. And then I'm gonna bring order underscore customer underscore ID, order underscore status, and then I need to create the order underscore month, right? For that, I'm gonna say from underscore Unix time and cast order underscore date divided by 1000 as int, and I'm gonna get a substring of this because This is going to give me y hyphen mm hyphen dd. So I need to get 7 characters from this string. So I'm going to do 1 to 7 as order underscore month. Okay, from default dot orders underscore scoop. Partition. Okay, got it. So let's try to say insert override orders underscore avro partition order underscore month. Okay, this looks good. Seems like there is a problem in the next statement. So select order ID comma to underscore date. So, oh yeah, okay, this is not needed. Still there is a problem. Okay, insert override orders underscore avro partition order underscore month. Um, Select order ID to underscore date from underscore Unix time cast order date as int order customer ID order status. Okay, let me fix this. Okay, now the problem is we have missed one bracket over here. Okay, so let me do this. Uh, Insert override orders underscore avro partition orders underscore month. Let's just run the query and see. Okay, the query is returning the result, but then I'm not able to. Oh, insert override table. There you go. So you got to be very careful with the syntax over here, otherwise you'll get into a lot of trouble. Now, insert override table is pretty easy to remember, but for some reason I missed it, and we wasted a good 3 to 4 minutes of our time in creating this. So when this finishes execution, we will complete step number 5. However, before we conclude that step number 5 is complete, we need to do some validations. So let's try to recap what we have done here. We have set 3 parameters in Hive so that it enables dynamic partitioning, and it enables a non-strict mode in dynamic partitioning. Non-strict mode is very important because you have an empty table without any partition. If the table does not have any partition, and if the non-strict mode is not set, even though the dynamic partitions are true, Hive is not going to insert because it does not have a basis from which the partitions can be created. But when you make non-strict mode enabled, Hive now understands how to create those partitions and creates them dynamically. Now let's look at the folder itself. Okay, so dfs-ls user/hive/warehouse/retail.db. Okay, and it has orders underscore avro. If you see, it created multiple folders. Okay, now each folder is for a partition. Okay, and the partition is 2013, 09, 10, 11, 12, so on and so forth, as mentioned in your problem statement. Now this concludes step number 5 and step number 6 together. Okay, the next step, in fact, the next 2 steps is to run the same query that we ran in 3 and 4 in Hive and Impala again. However, this time the table is order underscore avro. It is orders underscore avro. So let's try to run this on Hive first. I have the query copied already. All I need to do is to change the references of orders underscore Sqoop to orders underscore avro in all the places I used this table. Okay, so I'm going to say orders underscore avro. Do I have any other references? No, I don't. So let's run the query. Now I'm gonna go to my Cloudera and I'm gonna show you something. Okay, so over here, let's say show databases. Now it only shows the default database. It does not show the retail database we created. So that is why we need to invalidate metadata so that the new metadata in Hive can be loaded by Impala, and then Impala starts to understand whatever Hive understands, right? So let's say show databases now. This time you can see retail. Now I'm going to use retail here too and paste the query so that I can do orders underscore avro here too. I'm going to do orders underscore avro. Yeah. So Impala does not like expected all case instant. Okay, we'll fix this. Okay, we will fix this. Let's try to wait for the Hive part to finish so that we can conclude at least one step, and then I will think loud while fixing this, and we'll fix this eventually. Okay, so let's wait for this to finish first. Okay, so we have the result here. We have the result in the way that we wanted, including the partition data. Okay, so this concludes one step at least, if not the other step. This is step number 7. So we will return to look at how to run the same query in Impala for step number 8 and also fix the issue we see over here. Okay, so we have an error when we ran the query. It did not like the way this avro data is formatted. Now this complaint saying date cannot be converted to an avro type in Impala. Now when I look at Impala documentation over here, it says currently avro tables cannot contain timestamp columns. So to store date and time values in avro as a workaround, you need to use string representation. So this essentially means there is a limitation in Impala to do the query when you have date column. Now earlier when we did a query, it worked because that column named order underscore date was a big int, which was Unix time in milliseconds, and hence Impala did not have any problem executing that query. But right now this is a new table, and this table points to is stored as avro, and while Hive understands all the nuances of avro, Impala still seems to be lagging behind in those terms. Or the Cloudera version that I have has a version of Impala which is not yet capable to understand dates. The current version may be capable, but I don't know. This is the version you'll be given in the exam, so that is a limitation for us, right? So in the best interest of not wasting your time, I'm going to remove this step from the list of steps that you need to perform. Okay. The next step of the problem is to evolve Avro schema related to orders underscore Sqoop table. Now, evolution of a schema means the change in schema over the period of time. Over here, the change is update to the same schema where two more fields are added. So we are going to add orders underscore style and order underscore zone to the schema that is backing orders underscore scoop table. So let's try to understand where the schema is. We have created the schema in the past during this video and we uploaded that to HDFS. However, let's try to investigate once again. So let me say show tables on Hive. So I have a list of tables and I'm going to do describe formatted orders underscore scoop. As you can see, this is the schema, right? So let me copy this and get this Hadoop hyphen get, sorry, fs hyphen get. Okay, now as you can see orders ABSC, right? So I'm gonna do sorry, let me do vi. Okay, now this is not the right file, I'm sorry. So rem orders.absc, yes, ls, there's nothing. So let me do a get again on Hadoop. Less, okay, now gedit orders.absc. Okay, so the next step is to add two more fields. So all I'm going to do is copy this part and paste it after the comma and add a comma here. Okay, so this replicates. Now order ID, order date, order customer ID, order date, order customer ID. So these are the two fields that I kind of copied over so that they can be duplicated. Now we need to add order style, which is a string, say order style, and then call this a string. Column name is order style and SQL type is 12 because string is 12 over here. And then I'm gonna add something called as order zone. So wait a minute. So order ID, order date, order customer ID. I have order status here. This is order style, and then this is going to be order zone, and I'm going to do order zone over here. Okay, I will let the rest of it be the same because we have order status, zone, style, customer ID. So order date and order ID. Good. Let me save this. Okay, and I'll close this. Now let me copy this to the same location again. Okay, hyphen copy from local, and I'm going to do hyphen f option uh, because I'm going to overwrite the file which is already existing over here. Okay, I'm going to copy, paste. Okay, now if you look at Hive, the current Hive metadata shows that it has 4 columns, right? Now we have changed the backing ABSC file, which is providing schema. Now let me do the describe again. Let's look at this. Now, as you can see, ordered zone and order style are additional columns that were created as a part of this. Now, let me do select star from orders underscore scoop limit 10. Okay, you still got only 1, 2, 3, and the two nulls are the ones that we just inserted, and the order status is the last one. So these two fields are now represented, which means this schema has evolved. Now let's look at the next part of the problem. Next part is to insert two records into orders underscore scoop table. Now inserting is very simple again. So I'm going to do insert into orders underscore scoop, enters into table, orders underscore scoop, and I'm going to say partition is order underscore month equals, I'm going to use 2014-09 as my partition. You can use any partition of your choice. I'm just using one of them, and I'm saying values here. Let me say order ID is 0, and then order date is some date. I'm just going to copy this date, and then 11567. Then I'm going to do this one is a string, so I'm going to say XYZ, and then this one is like, it's a 9, and then closed. Okay, create temp file for insert values expression of time TOK or not supported. Okay, so let me fix this. Okay, here is the problem. The first part of the problem is orders underscore scoop table is not partitioned. If you look at this, it was orders underscore avro table that was partitioned, but not orders underscore scoop table. So let me remove partition related code from this SQL query. The next part of the problem is the string is not enclosed in double quotes. Okay, so let me use a number which is 8,000, a bigger number. So as you can see, even for inserting records, Sqoop is using Hive is using map and reduce. Because this is the very nature of Hive. It has to use map reduce because the data that is stored in the background is in HDFS, and everything that you do in Hive is converted into map and reduce jobs. So it took 25 seconds. Now this completes, that's the step number 9, which is to insert two or more records. Let us insert another one. Well, you can insert as many as you want, because now you understood how to insert. You can do this repetitively any number of times. The next step after this is to write the same queries that we have done in the past and run them on Hive and Impala again, just to check that inserting data into Hive did not mess up the structure of the data. Because as I mentioned earlier, Hive is only exposing the data available on HDFS in the form of a table, but the backing data or the backing data file is still a file and not a table. Okay, so let me run this query here. Okay, while it is running, I'll try to open Impala shell as well, and I'll run the same query over here. Okay, error encountered inner. First of all, we need to invalidate metadata because we changed the schema, right? And then we will have to fix something, or should we run this directly? No. So let me go back to the blog again. The query in Impala is same as the earlier query. I don't know what is wrong with this, but let me try again. Okay, maybe I need to do this. No, not even this. I'll use A, okay, instead of inner, because I'm afraid That inner may be some sort of reserved word within Impala. Yeah, there you go. As you can see, this worked, right? So let me correct my solution over here too, just so that you guys don't face a problem when you copy paste this and run the same query. Okay, where is inner? Okay, makes sense, right? Now, this completed in 14 seconds, but this thing took 120 seconds, and we have seen this in comparison before. Now, this ends the solution to problem number 3. I hope you enjoyed this video. I'm going to make more videos to help you in preparing for the CCA 175 examination. Good luck and see you later. Bye.